Welcome to Invested in Climate. Protecting the planet and decarbonizing the global economy is the challenge of our time. We all have a role to play, and the opportunity we face is unprecedented. Invested in Climate aims to help people do more to address climate change through their work, investments, lifestyle, and activism. I'm your host, Jason Rissman. I support a growing community of top climate and ESG leaders as the Chief Experience Officer at NationsWell, and I'm an advisor to the climate practice at IDEO. I'm also an investor and startup advisor, and when it comes to climate action, I know I'll be a lifelong learner, always looking to have more impact. If you like what you hear, give us a good rating on Apple, Spotify, or wherever you found us. Sign up for updates and suggest ideas for future episodes at investedinclimate.com. Follow us on social, subscribe, and spread the word. Thanks for joining.
I understand the value of community and network in having good mentors, having a ladder, having companies that are in the same or adjacent industries lay those bricks for you piece by piece, because the valley of death that's real. You need people with little cups of Gatorade on the path through the valley of death, and navigating this journey, especially in climate tech solutions, which typically are going to be interacting with real things.
Hey folks, perhaps you've heard of the valley of death. It's the phase of development that often kills off startups before they can reach scale. One key challenge is needing to test and refine their technology and gain true validation. For a few lucky startups, this is where the Wells Fargo Innovation Incubator comes in to help them develop pilots that provide the insights and credible third-party endorsement needed to grow their technology. The incubator is part of the Department of Energy-backed National Renewable Energy Lab, an institution that's central to the United States' investment in renewable energy. Today, we're joined by the director of NREL's Innovation and Entrepreneurship Center, Trish, who oversees the incubator. And we're also joined by the founders of two startups that recently participated in the incubator, Adam Cohn from NineDot Energy and Tanya from Community Energy Labs. We talk about what makes the incubator unique, how it's helped these two companies, what they're aiming to achieve, and much more. Enjoy. Trish, Adam, and Tanya, welcome to Invested in Climate.
Nice to see you, Jason.
Hi.
So great to have you all here today. Where do I have you each dialing in from?
I'm calling in from Golden, Colorado.
This is Tanya, and I am in sunny Portland, Oregon.
Fantastic. What about you, Adam?
This is Adam. I'm calling in from the Big Apple, New York City.
All right. Seems we have a truly cross-country conversation. Let's dive in as we have a lot to talk about. Trish, let's begin with you. Tell us about your organization and the role that you play.
Absolutely. So our organization is the NREL Innovation and Entrepreneurship Center within the National Renewable Energy Laboratory. And we are an externally focused center that runs half a dozen incubators, including the Wells Fargo Innovation Incubator.
Amazing. Before we go deeper into the Wells Fargo Innovation Incubator, let's first understand the umbrella organization that you're part of, NREL, or the National Renewable Energy Laboratory. It's a U.S. Department of Energy-backed institution that has 3 national centers ranging from bioenergy to photovoltaics to wind, as well as 3 collaborative research facilities, 16 different research programs, invests about $670 million a year across solar, wind, fuel cells, geothermal, bioenergy, buildings, vehicles, and much more. Last year, you published over 2,000 scientific materials. You have over 1,000 active partnerships and have produced almost 700 patents and employs over 3,000 people. Did I get that right? And is it fair to say that NREL is really the backbone of the United States' exploration of renewable energy?
Yes, it's a lot, and absolutely it is that backbone. NREL is all of the things you just mentioned, plus it has a mandate to get technology out of the lab and into the market, which is primarily why the center I work for exists and why it's so important that we work with startups and use those disruptive technologies to get clean energy out into the market and begin to accelerate the energy transition.
Great. So coming back to the Wells Fargo Innovation Incubator, let's go deeper into the types of companies you aim to support and how you find them.
We support companies who are in that earlier stage, usually hard tech. And why we've focused in on hard tech is there's just a longer cycle from getting from idea to market. And there's often some pretty substantial valleys of death for tech companies like that. It takes more capital to get to a prototype built and get interest from investment. So the Innovation Incubator, or the Wells Fargo IN2 program, was really invented to help fill that gap. One of the key differences is the way in which we source companies for the incubator. We have a vast domestic channel partner network made up of incubators, accelerators, and university programs across the nation, which serve as our pipeline of innovation to apply to the program. And then once we do a rigorous down selection process, which involves our technical experts at NREL, the Wells Fargo board, as well as a separate industry board to select the final companies that get in, they receive $250,000 of non-dilutive funding, which goes specifically to working on a technical project that they do at the laboratory with the help of one of our expert PIs or principal investigator researchers. So that what makes it really unique is that we are utilizing the multi-million-dollar facilities and world-class experts at a national lab to sit essentially on the team of a startup for a very short period of time to work on a project that's actually going to move the needle for them and help them get to market faster or accelerate their progress.
Wow, what a unique opportunity. About how many companies have you gotten to work with to date?
In the IN2 program, we've served 65 companies so far and more to come.
And what's happened to those companies? Have you been able to track how much capital they've raised or how much they've grown following their participation in the incubator?
Yes, absolutely. There's been thousands of new jobs created, which is one of the engines that startups do, is create new jobs. And also they've raised more than $1.6 billion in follow-on capital since joining the program as well.
Incredible. Trish, we've talked broadly about the value of piloting to help companies get through the technology valley of death. And of course, not all companies get to work with the incubator that you run. And so I'm curious, what advice do you have for other companies that need to get through that same valley, that need to figure out how to do some pilots, but don't get to have the type of support that you offer?
This is one of the most difficult problems. So we have multiple valleys of death. We have technology valley of death. We have a commercialization valley of death, where often those pilot problems come into play. My suggestion would be get out there and talk to as many companies, corporates, small businesses, schools, whatever you can that will be willing to raise their hand and be a first mover to test out your project or your product. It is one of the most critical things in getting an edge in the market. So I would also just want to reach out and say to all of you who are thinking about testing a new product or technology that please do it. It's something that companies and corporates need to take that risk, and it will really help move the needle for everybody if they do. So raising your hand and being first, it's scary, but we need more people to do it.
This seems to be a great time now to turn to Adam and Tanya. Before we hear about your experiences as cohort members of the incubator, let's first just learn about your companies. Tanya, let's start with you. Will you tell us about Community Energy Labs, the problem that you're trying to solve, and what led you to found your company?
Absolutely. Yeah. Thank you for having us. Community Energy Lab solves a problem that building operators find complex, frustrating, and very expensive. 40% of global carbon emissions come from building operations and primarily from electricity use. So we're looking at an industry where by 2030, many communities have decided they would like to be carbon neutral or significantly reduce their carbon impact. However, at the current rate of change in the buildings industry, if building systems were to turn over at the rate that they do now, we're over 150 years out. So we're trying to enable communities' decarbonization goals by 2030. So we have a technology that speeds that adoption, tries to do what's going to otherwise take 150 years to do in 7 years. Our technology is an IoT and SaaS platform that enables clean, all-electric, self-driving buildings. It controls the heating, ventilation, and air conditioning in buildings in order to keep people comfortable, but at the lowest possible energy and carbon cost. The problem really here is that we focus mostly on commercial customers and almost exclusively on publics, K-12, city, state government, churches, community buildings that have difficulty funding the types of solutions that traditionally have been available to get buildings more efficient, or in this case, more carbon neutral, which is big retro commissioning projects. They need something quick, they need something fast, they need something effective. And our platform was explicitly designed using government funding to try to reduce the cost and complexity of the type of applications available for commercial customers, 90% of whom don't really have a quick, effective, simple, cheap solution to this problem of building controls, but need it.
Thank you so much, Tanya. Definitely a niche in the market that we don't hear that much about. And it's so great to understand that you're focused on that and that there's a whole ecosystem around it. Adam, your turn. Tell us a bit about NineDot Energy and your founding story.
So my founding story actually started at the US Department of Energy and has some NREL context. I thought I'd tell that here. So I was a postdoctoral fellow at the Department of Energy. It's kind of a non-traditional path for a newly minted physicist to work in the federal government. I was working in the solar office back in 2011 to 2014, and I thought I'd be using my skills as a physicist. So I'd be looking at photovoltaics and electronics and optics, thinking about the next generation of hardware that we need to make cheaper and faster and easier and bring to market. And one of the first lessons I got as a postdoctoral fellow was that sometimes the science in the lab and then bringing it to the factory are the easy parts of bringing a technology to market. It's understanding the market and the decision makers and the regulations and the actual human processes, what we call sort of the soft part or the soft costs of going solar or getting clean energy. And so I kind of refocused my fellowship at the energy department, thinking about the non-hardware parts, the harder parts of actually clean energy. And so I met my two co-founders of NineDot Energy while I was at the energy department, working with researchers at the national labs and universities. And we were thinking about ways that technologies that are kind of commercially available off the shelf or newly emerging, how can we create new business model innovations that take them from just something on the shelf to something that's actually installed on the streets or installed at our homes and businesses. And so we've taken some of the ideas that we learned at the energy department, at NREL, and sort of through other people's experiences and started a clean energy company. And we're a development company, so we try to actually put things in the ground, the hard part of things, but it's all based off of these small innovations in marketplaces. And so now it was all roads led back to New York City, where I grew up, thinking about how we can take some of these hardware solutions and put them to new uses.
Fantastic. Thank you both for sharing your stories. I'd love to turn now to your experience with the incubator program. The incubator exists to help companies through the technology valley of death. And I'm really curious, what does that mean for each of you? Tanya, let's start with you again. Tell us a bit about your experience in the program. And I'm aware you've also participated in other programs ranging from CalSeed to Berkeley Lab to Elemental Accelerator to Google Startups Accelerator. What was different about the NREL experience?
This is my third company, and so I understand the value of community and network in having good mentors, having a ladder, having companies that are in the same or adjacent industries lay those bricks for you piece by piece, because the valley of death that's real. You need people with little cups of Gatorade on the path through the valley of death and navigating this journey, especially in climate tech solutions, which typically are going to be interacting with real things. I used to joke with my co-founder. She left the business. She's still an advisor last year. But we used to joke, we called it rabbitshoes.com. Traditional VC funded software is like, hey, rabbits, third most popular pet. They have big feet. They wear shoes, rabbitshoes.com. It's not that simple. We've got physical stuff that we're interacting with. We have complex solutions. And so it can take more time to develop those solutions, to test it, to refine it for scalability, particularly if you're trying to scale quickly. The research and development process can be, I don't want to call it tedious. It's exciting, but almost like drugs and pharmaceuticals, it can take a long time to sort of strike gold, if you will. So most accelerators are really focused on the business components. We also have, at this point, 5 SBIRs, 3 phase 1 SBIRs and 2 phase 2s. The one real difference with NREL before we had our phase 2s is that they paid for us to do demonstrations. If we could find a willing pilot to try, some crazy friend, family, or fool to try our technology and let it operate on their real world environment. We're like, hey, we think it's going to work great. Works in a lab, just super. Or it works in my house. I know, let's operate it on this school that has 1,200 kids taking their finals in the middle of summer. So in order to be able to find somebody who was willing to do that, you had to take some risk off the table. NREL really brought a lot of credibility in terms of bringing the technical support of the lab. So half of the grant goes to fund for the demonstration, and the other half to provide technical support and validation around the work that we're doing in the field. I think that really that demonstrating a project so that you have a project pipeline that has the trust of your target market is invaluable. Building that level of trust, establishing real world results from flexibility is so important. So for us, in the case of NREL, they funded 10 installations and we learned a lot. And then at the end of the day, we did learn a lot of technical things about aspects of our model that needed to be not shored up, but where we found additional innovations and additional value that we could deliver to customers. Aspects of our implementation process that could be made more efficient or eliminated altogether, therefore making it faster, cheaper, and even easier for the customer. Already a process that costs about, our implementation process costs about 1/20th the cost of competitive technologies on the market, energy management systems, and it only takes a day. So we were already faster and cheaper, but we found ways to make it even faster and cheaper when we did 10 pilots all at the same time last winter. So those things I think have been invaluable, is really taking risk off the table for early adopters and then helping us tweak the technical aspects or sort of shore up the measurement and verification so that we could build trust with the market that our technology was sound, trustworthy, and they should let us try it on their buildings.
Thanks, Tanya. We definitely want to circle back and learn more about what the technology is, how it works, and get into some of the details. But first, Adam, let's come back to you. Tell us a bit about how the incubator helped NineDot Energy, and how did you focus your participation in the incubator? What were the outcomes and what it led to?
I like to consider ourselves tinkerers, or we put together puzzles. And we've put together a few puzzles as a company that have worked really well and are scaling up. Our core business is developing stationary battery energy storage in New York City. And so we find a piece of vacant land where the power grid might be unreliable or high stressed or high cost, and we can install a stationary battery energy storage system that helps shore up that system. It takes in power when there's extra power available, and then it puts the power out when that grid will otherwise be dirty or stressed or expensive. What we wanted to do was figure out the next generation of this type of business model. And that's where this project with IN2 and NREL really helped. We ended up building the first what's called vehicle to grid project in New York City. So not using stationary batteries, but instead using electric vehicles when they would otherwise be idle, and start using the power that's installed in those cars and putting that back on the grid. The technologies are new, the vehicles are new, the business models are new. How do you implement it? How do you work with utility companies? How do you find customers? How do you put that whole puzzle together? We're starting that process with the IN2 program. In New York City, we're able to put together a group that had vehicles, a group that had the technology and software, and put all that piece together. So one half of our project is this demonstration, this first of its kind demonstration that can be scaled up. And the other half is working with researchers at the lab to understand what's going on, how is it working, but also how can we model the entire power grid and find out where the best places are to build more of these things, make this as valuable and scalable as possible. So this two-pronged approach of actually doing something, putting, in this case, rubber on the road and sort of electrons on the grid, while also studying it and seeing what comes next, what do we learn from this, is really a unique part of IN2, and we're really happy to be a part of it.
Trish, let's bring you back in. Is the experience that Tanya and Adam are describing typical? I'm aware that they were part of a cohort of more advanced companies and that you're often working with earlier stage ventures. Tell us what that means in practice for your team and the support that they offer.
Yeah, we had a demonstration cohort that Tanya and Adam were a part of, which was a fantastic test into the second valley of death we like to talk about, that commercialization valley, where there's often a death by pilot, and we want to have opportunities for the real world opportunity to test out. We think, as Adam said, that NREL offers a real value, and Tanya said it too, a real value in bringing in a third party that's world class, that has world renowned experts that can serve and take some of that risk away or nervousness away from others who are involved in that pilot process or that end customer who's testing things out for the first time. So how that's different from our typical cohort that we've run in the past is really we've focused in the past on a little bit more early stage technologies often, who do projects in the lab with PIs or principal investigators who are paired with them to help move the needle on a project from maybe a prototype stage to a prototype that's ready to be tested, or maybe they've got a really good design and they're working on a prototype. Those are all areas that we can certainly help with here at the lab to move them along a little bit faster and get the investment community more interested in what they're doing. Tanya mentioned it's a slow process, which it is with hard tech, and any edge we can give them in terms of helping evaluate and validate that technology by being part of this program and having the experts at NREL work on their projects and give them aid in any way that they need to be successful really makes a big difference.
Great. Thank you, Trish. And great to understand the different ways you support companies at different stages. Adam, Tanya, let's go back to you. NineDot and Community Energy Labs are really both fascinating companies, and so I'd love to spend more time getting to know them. Adam, will you kick us off this time? Your solution is focused on powering New York City with clean energy, and you focus primarily on energy storage. Tell us a bit more about why storage is so important, especially for a place like New York.
So New York State has some of the most aggressive goals for clean energy in the nation. We're trying to put on gigawatts and gigawatts of offshore wind that will turn on when the wind is blowing out in the Atlantic Ocean. We're going to put on gigawatts and gigawatts of upstate solar energy that's going to provide power when the sun is shining. And we're going to build lots of transmission lines that bring that to the hub, to New York City, where we need the power exactly when people are going to turn on the lights or their air conditioning or their heaters or charge their electric vehicles. Energy storage is that buffer that pulls in the power when clean energy is available, has it sit, and then puts that power back out when there's demand. And so energy storage is a key piece of the clean energy puzzle for a place like New York City. Now, what's really unique about the project we're doing with NREL, it's that as we're doing this, we're also increasing our electric load. There are 2 million vehicles driving around New York City right now. And within the next decade, next 15 years, most of those vehicles will be electric. And so they will be a new source of load for our power grid. They'll be charging up with hopefully clean energy. But just like today, most of those vehicles will be idle most of the time. They'll be sitting parked in garages or in driveways or along the street. We can think about those parked cars as batteries. We can use them to also soak up that clean energy and be like a lung for the city to breathe in when we have clean energy and then breathe back out when our buildings and our homes and our businesses need that energy. And so energy storage is a key part, is kind of the glue that makes clean energy possible.
Thanks, Adam. Let's get into the technology. From a tech perspective, what's unique about what NineDot is doing? We hear a lot about different energy storage solutions, and so I'm curious, what are you doing that's really different?
Our main product is actually community scale battery energy storage. And so what we do is not install gigantic farms of battery packs that replace peaker plants directly where the peaker plants are. And we don't build battery packs at people's homes and businesses. Those are both important pieces of the puzzle. But we install basically community batteries on 5,000 square feet. You can still find 5,000 square feet in New York City. You can install enough power for thousands of homes. It's sort of like community solar, but shrunken down to an urban scale. We can install these assets that help the power grid, they get the economies of scale of big systems, but they provide the distribution benefits, or the benefits to local communities, to local power grids of smaller resources. So I like to consider it a sweet spot for the marketplace. And so we've developed a business model around community energy where we install these projects in the highest stress parts of the power grid. And what we get is a bank of credits for providing this value to the power grid. And then we sell these credits as to subscribers all throughout the city. So we provide clean energy, but we also are able to have a community aspect where people actually are participating, opting into providing local clean energy. So we like to think of it as a community energy project where everybody gets to participate, everybody gets the benefits, but shrunken down to really small scales. They're not acres and acres of land, but really small spaces. That's our core business. With vehicles, we can expand that to a new sector.
Adam, working in a place like New York City, especially at a community scale, really requires not just technology, but also engaging a range of stakeholders. So I'm curious, what sorts of partnerships have you developed? And what have you learned in the process?
Every project is a bit of a snowflake. You have to understand the local community. You have to understand how to work with the utility company and understand that local power grid infrastructure. You have to understand the zoning rules and you have to understand the permitting rules. And so there's so many pieces of every project that make it unique. I'll give two examples. So one of our projects is in Pelham Gardens area of the Northeast Bronx. And we've kind of been welcomed and embraced into the community. So we're building a project on a formerly vacant piece of underutilized land. And across the street is an elementary school. And we have been working with the STEM program, their afternoon program with the students, to have them make a 140-foot mural that describes the process of clean energy. And so the whole community has become involved in taking ownership of this project. And it's been really rewarding to work with the teachers and the students and the parents and the faculty there. So that's kind of one aspect, working with the local community. Another aspect is making connections that you wouldn't otherwise. And so through our IN2 program, it's actually a partnership of 3 different startups. Any one of us could be the group that applied to NREL for this program, but we ended up all working together. We're actually working with a group called Revel Transit. And if you're in New York City, you'd see a bunch of blue electric vehicles driving around, sort of the taxi cabs of the future. It's an all-electric car fleet. They're building electric vehicle charging stations. They have electric mopeds all throughout town. And so they're our host site and providing vehicles for our V2G demonstration project. And they're a New York City-based startup that's been really fun to work with. And then we also have a company called Fermata Energy that develops the actual charging station hardware and the software to support them. And so the 3 of us came together for this demonstration project. And what I find is every project, no matter how big and small, has this story, this sort of cohort of people coming together to make it possible. And that's kind of the most rewarding part of working in clean energy.
Thanks, Adam. Those are some really powerful examples. We heard Trish talk about the importance of pilots and getting through the valley of death, and it seems that you've done some great pilots. I'm curious about your overall traction and how you're able to measure your success. Do you have metrics yet about how much energy you've been able to provide to New York City? And what's the scale that you're able to reach right now?
We're in the process of putting together tens of megawatts of projects for thousands of homes. And we have a pipeline of projects that we're trying to bring online of hundreds of megawatts. But let's just put that in perspective. The goal of New York State by 2030 is to have 6,000 megawatts of energy storage. So we're a small part of that puzzle. And the idea is that we need something like 17 or more thousand megawatts by 2040 and 2050 in order for the grid to actually decarbonize. We are one piece of a much larger clean energy puzzle. And we're finding areas where you can bring a lot of value with relatively small projects, and then you keep kind of rinsing and repeating them. We're not building one mega project, but lots of small projects that get added together to have a significant impact.
Great. Thanks, Adam. Tanya, let's turn to you. Community Energy Labs focuses on making building control solutions affordable and accessible for community building owners. I'd love to first understand the market that you're serving. What are community buildings exactly, and why are you focusing on them?
Well, if you look at commercial buildings as a whole, are you in a building right now? Is it using energy? There's a good chance that it's either a commercial or a multifamily building. So as a whole, 25% of the square footage that belongs to commercial buildings is owned by public entities. So that could be K through 12 school districts, cities, counties, state, federal buildings, and their property portfolios are massive. They're also very energy intensive, and their procurement, the reason that we focused on them is because we were talking to folks in the early days when it was just a gallon or slide deck. I was planning to do something more closer to what Atom and NineDot do. So originally I was looking at virtual power plants, microgrids, which is different from what Atom is doing, but on that side of the energy generation equation, or in front of the meter, you might say, or aggregating behind the meter resources. And I wasn't sure what I wanted to do for a company, but I knew I wanted to do something that was contributing to decarbonization. So I had been talking to a lot of municipalities, cities, states, schools. I had also been talking to energy service companies, utilities, not a lot of residential customers, but a lot of commercial, and then also like hospitals. And I was asking them, what is the biggest barrier to you for decarbonization, energy efficiency, and energy? And if I could wave a magic wand to take away your biggest headache or your problem around those things, what would it be? And a couple things kept coming up over and over and over again. With one hospital and another university, their responses were really funny to me. I said, what if I could wave a magic wand? What would I do to take away your pain? And they're like, get rid of my tenants. I can't. It's like, well,
that's another problem.
Yeah, that's like, well, So there's this archetypal fight between the energy manager for these portfolio companies and these. When you think about a school, when you think about the federal government or the state, they have these like huge old buildings. There are 2 school districts that we're working with right now, each of which has 32 campuses, millions and millions of building square feet. The average age of their buildings is 61 to 78 years old. These are old buildings. They have old systems. Energy is their second biggest cost after labor. So we saw that already, even today, it's a huge cost for them. But the way that they manage it puts them into conflict constantly with their occupants. So this is 25% of commercial floor space already has this problem where energy is a huge cost that they're trying to manage. But the tools that they have to manage it mean that they're like, you've got an energy manager, a custodian, who's like fighting with teachers. Like literally they talk about fighting. It kept coming up over and over and over again in these sectors. We have these old buildings, this old stuff. And it's like, we are the, what do you call those little heaters? Those little mini heaters? I'm like the mini heater police. Like my job is to go snatch these heaters from teachers or to nag everyone to close their doors. And I hate it. I hate that we have to make this choice between comfort and being good stewards of public money. And then when I said, well, what do you do about that now? They're like, well, we try to pass bond measures so we can upgrade our facilities. And when we do, we get these controls packages that are usually bundled with like HVAC upgrades. But those are multi-million-dollar projects. And when you start thinking about the procurement process for public entities, we're talking about pass a bond measure, then issue an RFP, then go the whole RFP and contracting process, and then do the job. And they're supposed to be meeting greenhouse gas emissions goals by 2030. Like you're not even going to get through that whole process by 2030. So it was clear they needed something cheaper, faster, that would help them be impactful and that would also address comfort. And then I had also heard when I talked to on the utility side, I had been looking at price signal based programs or automated demand response programs at one point, again, virtual power plants and batteries. And I remember interviewing one residential customer where I said, hey, do you participate in our peak time rewards program? And she said, oh, is that the program where you pay me $5 a month to turn off my AC on the hottest month of the year? And I said, yeah, it's that program. She's like, F no. Oh, okay. Right. So I just knew that there had to be a problem that we were solving for customers. And in this case, it's complexity and money. The complexity of the new and emerging building electrification laws, how that's intersecting with utility prices and time of use prices and demand charges, how that's already a major pain point. And then the complexity of trying to balance that increasingly more complex building code and energy environment with making people comfortable and happy. So at that point, I felt like I just was amazed. I said, well, surely someone's thought about this. It's a big enough market. But when I went out and started looking, I realized that it was really a pretty recent development that these pressures had started sort of squeezing folks. It was really somewhere around 2019 that just the pace of policy adoption around renewable energy, carbon limits, energy code updates really started to just take off in the US. So, yeah, I just looked around and was like, there were a lot of very good reasons, I think, why this issue wasn't being addressed. And I went out and found a technology that could do it.
Let's go deeper there. Tell us, what is the technology? How does it work? And what really makes it unique?
What is not unique about it, let's start there, is that it's an IoT and software as a service platform. So there are solutions on the market, building automation systems, energy management systems. Sometimes I joke with folks and I say, hey, these traditional systems cost $150,000 to $300,000 installed. You do it during a big upgrade. It's typically housed on its own subnet, its own network, on a beige PC in a windowless mechanical closet. And to people who don't work in buildings, they laugh because they think I'm joking. And I'm like, I am not joking. I am seriously considering issuing a calendar called Mechanical Closets of 2024. Lots of PCs running Windows, not a joke, 98. There's a lot of tech debt in the existing equipment. So in a way, we have an unfair advantage because since that time, we're not invested in that software stack. There are a lot better frameworks for both user experience, mobile experience, IoT, very small industrial computers, cloud-based solutions, and cloud is so much cheaper now. So there are ways to very securely make the whole tech stack a lot cheaper and more user-friendly. So that's not unique about us. That's what any software company would capitalize on, that we don't have that same amount of technical debt inherent in our solution. But the part that's very unique, and the technology that I found to address that, is something called model predictive control. So model predictive control is a technology that's been around for 30 years in process engineering. It's been used in industrial processes, self-driving vehicles, and it's a form of control that differs from the existing types of controls in buildings. So traditional models use something called rules-based control. That's where you have an expert that will put a typical algorithm in there, like if so-and-so happens, then do this. So you can program in these algorithms, but they require expertise to tune and calibrate. And the other is proportional integral derivative controls, controllers that basically look at, say, a set point in a room or a set level and the existing performance and then try to bring existing performance up to that level. Well, model-based control is very different. It's like having a brain. It says, I understand how this underlying system works, and I can therefore make predictions about when I make a control action, what will happen to this system. So it's a lot like having cruise control for buildings. The difficulty being that a building is not like a car. Every single one is not exactly alike. It doesn't come off of an assembly line. So understanding the thermal dynamics of buildings is very difficult. So I found a researcher who had been looking at ways to make the underlying model structure more resilient and cheaper for the types of small to mid-sized buildings that we would be looking at. And then I had some ideas on how to make the data collection process using modern database and query technologies more efficient as well. And we joined forces. He received a Department of Energy Cooperative Research and Development Agreement, and I got a phase 1 SBIR, and we combined our research and development. And I will say that I think after the first year, when we actually saw results where we were beating a system that cost 20 times ours by 30% straight out of the gate. The first time I saw it, I was like, that was cool, but probably it was beginner's luck. That school might have been new. But then when we did it in a totally different climate zone on 40-year-old equipment with a state-of-the-art competitor, I really was like, oh my God, we're going to save the world. So the technology is called model predictive control. Our main innovations were finding some model structures that use reinforcement learning and telemetry data from the building to update the underlying model and its predictions, and then finding very efficient ways to use data to make predictions about the underlying parameters that are used to set up that model, making model setup and tuning faster and autonomous and cheaper. One way I like to describe it to non-technical folks, I feel like since we're on this NREL thing, I'm going deep, but I say that it's like Snapchat bunny ears. The Snapchat makes a quick and dirty model of your face, and then the bunny ears sort of follow your head around the screen while it moves. Ours is very similar. It's creating a quick and dirty model of the thermal dynamics of the building and then operating the building as close as possible to the optimal measured indoor air temperature while reducing the energy consumption. So it's going, I know what's going to happen if I heat or cool this room. and I understand how that's going to impact energy. And so it's basically just, it's got the whole building on, it's like spinning plates. I know how much longer this plate can spin before I have to apply more force to that spin.
Amazing. Tell us about your traction and what you've been able to achieve so far with your Snapchat bunny ears for community buildings.
We entered the market in 2021 was when it was first more than one person. We received our first R&D funding, and we really just tried to work with the data collection technology through 2021. Now in 2022, we installed our first 3 pilots, and then with NREL and other funding within 2022. So the first 8 months of 2022, we installed 3 early installations. And we had done testing, like I said, we'd done R&D testing before that. So testing in a lab, testing in people's homes, a test here, a test there. So we did 3 commercial installations between January and August of 2022. And then we did like 6 in a week in the first week of like October, November. And then by the end of the year, we had 14 installations. This year, I believe we have 55 new districts in the pipeline. I don't know how many of those will get to the finish line, but we already have, I believe, over 20 queued up just to be done in June and July. What that looks like too is that we have over $230,000 in annual recurring revenue. Our first actual renewal is coming up this fall, and it looks like it's going to happen. So we're like, woo! And what's best is that even those first 2 pilots, the great thing about these districts is it's very hard to earn their trust. But if you earn their trust, and when we showed those savings and those really incredible results, we had done the work. Again, it's part of the reason we didn't take VC right away. We had done the work to make sure that we felt very certain the technology would work. I mean, again, I was surprised. So that one district, when it saw that it was working in 2 buildings, said, okay, let's do it at the whole campus. When they saw that work, this year they're expanding to 8 campuses. And their goal by the end of 2025 is to expand to all 32 of their campuses. And so that's really what we've done is all of those early installs have been, onesie twosies with different portfolio managers with the idea that it's a proof point and that we'll expand commercially to all of the buildings in their portfolio. So we grew 10x in our first year in operation between 2021 and 2022, and we're on track to grow by about 300% this year.
Incredible. Congratulations on that momentum. I'd love now to hear about what's next for each of you. Trish, do you have new cohorts coming aboard? What's the future look like for the incubator?
Yes, we do have new cohorts coming aboard. In fact, I just flew in from St. Louis today, where we onboarded our latest cohort in agriculture, which we haven't talked about today. We've been talking about buildings and electric vehicles and batteries, but we actually have with the IN2 program a whole track on ag tech and agriculture, which maybe we can talk about another time. Also, fantastic results happening there. And then as for the future beyond that, we're looking at more demonstrations, more cohorts, more impact across the building sector as well.
Fantastic. Congratulations on the new cohorts. And absolutely, I'd love to do another episode on ag tech. Adam, let's turn to you. You talked about playing a small role in a complex, large city and being a small piece of the puzzle there. Looking longer term, what's the role that you expect to play and what do you need to do to get there?
Over the next few years, I expect we'll be building hundreds of megawatts of battery energy storage. And I'm hopeful that the project that we talked about today will have hundreds of thousands of vehicles participating in the clean energy future. I'm really excited about what comes next. So I like to consider our company not just a development company, but also a laboratory. So how do we keep tinkering? How do we keep putting together new pieces of the puzzle? So how do we find new marketplaces? How do we find new technologies? And how do we bring them to marketplace? And so we're constantly thinking about what comes next. And a part of that is, as I think Tanya and Trish said, is being part of a community and listening to what others say and hearing what others are doing. It's all about partnerships. You can't do these things alone.
Thank you, Adam. Tanya, take us home. Tell us about what the future looks like for your company. It sounds like you're growing really quickly. So what do you expect the next few years to look like for Community Energy Labs?
Well, if we focus on the smaller picture, I would say that our company is looking to take that $230,000 in annual recurring and the $3 million in paid pilots, demonstrations, contracts, and swap that around, reducing the amount that we have from contracted jobs to just pure commercial sales and sort of swapping that ratio. Our ambition is to capture 13% of the US K through 12 commercial square footage in the United States, which would make us $106 million a year in ARR and $120 million in non-recurring revenue company by 2030. So that's what I say is the small idea. But the big picture is that Project Drawdown says adoption of building automation systems is a solution that could reduce 7 to 11 gigatons of CO2 equivalent by 2050. And we want to be part of that solution. So software and machine learning they've revolutionized every aspect of our lives. And we're trying to get folks to join us in harnessing those technologies to reduce carbon emissions from buildings and be part of the solution.
Amazing. Tanya, Trish, Adam, thank you so much for your time today, and best of luck with all the important work that you're doing.
Thank you, Jason.
Thanks, Jason.
Thanks for joining us for this episode of Invested in Climate. Please remember to rate us on Apple, Spotify, or Google. Find show notes, sign up for updates, get in touch, and visualize your climate action at investedinclimate.com. This podcast is for informational and entertainment purposes only and does not constitute financial, accounting, or legal advice. Thanks again.